So earlier class we saw the properties of matrix multiplication, and also we saw the distributive and all those things. Okay, where we include the addition also, and the property that's interesting, and the other properties of the identity matrix and the null matrix. So now we will see the transpose of a matrix. Do you know what you mean of transpose of a matrix? What? Row into you have to basically rotate the matrix, make the rows to column and column to row. Okay, so that's what a transpose of a matrix, and it has a very interesting properties. Okay, for any matrix, this is actually very simple. First property is, if A is a matrix, transpose of A and to its transpose is equal to A. Am I right? So shall we take an example? So transpose not necessary to be a square matrix. Okay, it can be a any matrix also, any rectangular matrix. So let us write A will be equal to 1, 2, 3, 4, 5, 6. Tell me, what is A transpose?
1, 3, 5.
1, 3, 5, 2, 4, 6. So A transpose of a transpose? Take a transpose of this, right? 1, 3, 5, 2, 4, 6. So they both are same. Am I right? So therefore A transpose of a transpose will be equal to A. Yeah, this is very, yeah. And this is also easy. The properties, what they say, the second property is, so you multiply a scalar multiplication. K, let K be a number, just multiplying with a matrix. I am taking a any number, multiply with a matrix A, and when you take a transpose of it, this will be K into A transpose. Is that correct? Will that be correct? Try it out. Okay, let us take A. Let us take the same number A. What is that? A will be, let A be equal to, tell me, 1, 2, 3, 4, 5, 6. And let K be equal to, let us take a simple number, 2. So then what is Ka? Tell me. I am doing LHS. So this is LHS I am going to do. LHS. What will be Ka? Tell me. K equal to 2. And A is this one, right? So 2 into 1, 2, 3, 4, 5, 6. This is a scalar multiplication, correct? So this 2 will be multiplied with every element of the matrix. So that will be equal to what? So tell me what this will be. 2, 4, 6, 8, 10 and 12. And now we have to take a transpose, right? Ka transpose. So Ka transpose will be what? Tell me.
2, 6, 10.
2, 6, 10, 4, 8, 12. Okay. So now let us do the RHS. So what will be the RHS? Tell me.
2 transpose.
Yeah. Ka transpose. Let us take A transpose. What is A transpose? Tell me. A is this, right? A transpose will be 1, 3, 5, 2, 4, 6. 2, 4, 6. So now, what will be Ka transpose? K is 2. 2 into 1, 3, 5, 2, 4, 6. So that will be how much? Tell me.
2, 6, 10, 4, 8, 12.
Are they both same? Okay, so this is also, so this is the second property of a transpose of a matrix. So similarly, and let us see the next one. What will be the next property? So the next property is, if A and B are conformable, that means you can do multiplication. Okay. For the product A and B, then this is a very interesting. For product A and B, then so then you take the transpose of So if A and B is conformable, that means if A and B is conformable, then you can multiply that matrix A and B. So what they say is, if A and B is conformable, then the transpose of the product will be transpose of B into transpose of A. Okay, so this is a very no, before that they had one more thing, third one, I missed that one, sorry. We will take this one, sorry. I missed one line. So if A and B are two matrix, not conform, means square, they equal matrix of same order, then only can add. So that A plus B transpose equal to A transpose plus B transpose. This is easy to prove, okay? Let us take A. A will be equal to what? Tell, say something 1, 2, 3, 4, 5, 6. You have to add with B, so the order has to be same. So the B will be equal to, say, let us take same order, right? Minus 1, minus 2. Okay, don't take all minus 2. Okay, then 3. No, I will not take 3. I will take 2, 1, and what happened? You take 0 and 5. So what is A plus B? Tell me. So LHS let us do. What is LHS? A plus B, correct? Tell me what is A plus B? 0, 0, 5. Oh, sorry. 5. 5, 5, 5 and 11. Correct? And transpose? A plus B transpose will be what? Just 0, 5, 5, 0, 5 and 11. So now let us try do for the RHS. So what will be the RHS? Tell me. A transpose plus B transpose. What is A transpose? 1, 3, 5, 2, 4, 6. And B transpose? Minus 1. Minus 1, 2, 0. Okay? Minus 2, 1, 5. So what is A transpose plus B transpose? 0, 5, 5, 0, 5, 11. Are they both same? Okay, so this is the third property of the matrix transpose. Okay, you should remember all these properties. Okay, because at the time exam you have to you can't do all these things and check it. Okay, though it is because once if you keep doing matrices, then you will by mind over the mind itself you know that, oh yeah, this has to be the same property. Okay, so but yes, that is not always advisable when it comes to matrices, because many times we do it wrong. Okay, and the fourth property is the interesting property I said. Okay, so if A and B are conformable, that means A and B can be multiplied. So AB, product of A and B, transpose of this will be B transpose into A transpose. So this we can prove nicely. Okay, so A and B are conformable. So we have to proper take the matrices. We will not take square matrix. Square matrix is obvious. Okay, let us take means not the matrices of the same order. So we are going to take A is equal to, if you remember, conformable means the column of the first matrix should be equal to the row of the second matrix. So let us take 2 cross 3 matrix. Okay, so 2 cross 3 means what? Let us take 1, 2, 3. Okay, minus 2, 1, 0. This is 2 cross 3 matrix. So for this matrix to be conformable with B, so B should have the same amount of rows as the, same amount of column of A as rows, correct? So this should have 3 rows. And let us take it, we don't want to take the same dimension. Let me take as a square matrix, 3 cross 3 square matrix. So tell me what will be 1, 1 minus 2, 2, 0, 1, okay, 3 minus 1 minus 1. So let us take these two matrices. Okay, so now we are going to check for this property. We can actually take 4 also. Okay, so if you want to, let us make it 4 so that will not be a, so then it will be, obviously we are taking a different matrix. So this, let us take it as what? 1, 0, 1. So what is this order? This is 2 cross 3 and this is 3 cross 4. So these two numbers are same. This is conformable. So can you tell me what will be resultant matrix order?
2 cross 4.
2 cross 4 matrix. We should get 2 cross 4 matrix. Okay. So let us take what is AB. Tell me what is AB. So we are going to find LHS. AB is what? Tell me. 1 plus 4 plus 9. 14. Good. The next one. 1 plus 0 minus 3. Minus 2. Minus 2 plus 2, 0, minus 3. Then this is 1 plus 0 plus 3, 4. Correct? So next one is minus 2 plus minus 2 into 1 minus 2 plus 2 0 and this also 0. Correct? Is that right?
That will be 3, right?
No, wait, na. See.
Minus 2 plus 2.
Minus 2 plus 2 into 0 into 3, na. So this is minus 2 plus 0 plus 0. So this will be minus 2. Correct? Tell fast. You should say first. You should tell me. Minus 4 plus 1. That became minus 3 and this is 0. So this is minus 3. Am I right?
So minus 2.
Tell me minus 2, 0. Minus 2. Right? So yeah. And now AB transpose. Not A plus B. AB transpose. This you can find it out. Right? Tell me what it's. 14, 0, minus 2, minus 2, minus 3, minus 3, 4, minus 2. Now let us do the RHS. Let us try to do the RHS part of it. What is RHS? First you have to find out B transpose and A transpose. What is B transpose? Tell me. 1, 2, 3, correct? 2, 3.
1, 0 minus 1.
1, 0 minus 1.
Minus 2, 1 minus 1.
Minus 2, 1. Minus 1. The last one is 1, 0, 1. And A transpose? 1 minus 2, 2, 1. 1 minus 2, 2, 1. Correct? 3, 0. Now what is this order, you tell me? This is 4 cross 3. Am I right? And this will be 3 cross 2. Okay, so obviously if, see there's another thing, interesting thing is if A and B are conformable, so then B transpose and A transpose will be conformable. Okay, the reverse won't be. If I write A transpose or B transpose, they won't be conformal. I can't multiply it. You got it? So now we can multiply and tell what is the answer. Tell me what is B transpose, A transpose.
Minus 1. No, 1 plus 4 plus 9. 14.
14? Yeah. Fast. Tell me fast. Tell me fast.
Minus 2.
Plus 2, 0, 0. That is correct?
And then 1 plus
1
minus 2.
Minus 2.
And then this was minus
1 minus 2, 0, 0, minus 2. Correct? So then this row and this column, right? Minus 2, 2, 0, minus 3. Correct? Minus 2, minus 2, minus 4, plus 1 is minus 3. Yeah, minus. Correct? The last one is 1, 4. Correct? And this will be 1 into minus 2, minus 2, 0, minus 2. Correct? Are we getting the same answer? Okay, hence proof. So therefore, So this is a very interesting property of the matrix transpose. Okay, and we can yeah, there are 3 more properties they given. Let me write it down. So the next property is if A is symmetric, then A transpose is A, and that's also very easy. See, if A is symmetric, then A transpose will be equal to A. So let us consider square matrix A. Okay, tell me a symmetric matrix. 1, 2, 3. So what should be? 2, and this should be 3 automatically. Then only will be symmetric. Correct? And here, tell me 1, 4. You change numbers. Why are you counting 1, 2, 3, 4, 5, 6? Okay. What? Minus 2. Then here should be minus 2. So this can be anything. Correct? 0. So this is a symmetric matrix. So what will be its transpose of it? Tell me. It's going to be same. Am I right? This will be 1, 2, 3. This is become. Then 2, 4 minus 2. Then 3 minus 2, 0. That's what it says. Correct? So this is a very obvious property. Simple. And yeah, and the interesting thing is, what if A is a skew symmetric? Okay. So can you guess what if, when A is skew symmetric, what will happen? If A is skew symmetric, you remember skew symmetric, diagonal elements will be 0, and the sign of the corresponding columns ij will be equal to minus ji. A of ij will be equal to minus A of ij. Sorry, A of ij will be equal to minus A of ji. So that was a property of skew symmetric matrix. So tell me what this will be. So then A transpose of a skew symmetric matrix will be minus A. Yeah, check it out. So let us take this example. Tell. So what will be, let us take, what is that? You have 1, 2, 3 again. So 1, 2, 3. So this has to be opposite sign, correct? So minus 2, minus 3. And let this be equal to, let me put it here 4. And this is minus 2. So this should be equal to 2. And this is 0. Correct? But is this skew symmetric matrix?
No.
Why?
The diagonal should be 0.
Correct. Diagonal elements has to be 0. See, the property is there, na? Because A of skew symmetric matrix property is A of ij is equal to minus A of ji. So then if A of ia also should satisfy. A of ia equal to minus A of ii. When this can happen? Only when A of ia equal to 0. That's why for skew symmetric matrix, diagonal element has to be 0. Okay? And okay, fine. Now let us do. What is the A transpose? Tell me. 0, minus 2, minus 3. Tell me, what is that? 2, 0, 2, 3, minus 2, 0. Okay. So isn't it is a minus A? So minus A will be what? Just adding on minus to it, right? 0, minus 2, minus 3, 2, 0, 2. 3 minus 2, 0. Isn't that the both same? Okay. So that's what the property of with the skew symmetric matrix also, transpose. So this is very, transpose has a lot of interesting properties. Okay. So, and then let us go for the last one. So that is something very interesting actually. If A is a square matrix, it's an interesting property because any square matrix, if you see, it can be written as a combination of symmetric and skew symmetric matrix. Okay, so seventh one is, if A is a square matrix, then A plus A transpose is symmetric. and A minus A transpose is skew symmetric. Okay, what is that? If A is square matrix, A plus A transpose will be symmetric, and A minus A transpose will be skew symmetric. Okay, and this is very interesting. So from using this property, you can show any square matrix can be written as a combination of a symmetric and a skew symmetric matrix. Okay, yeah. So let us try to say. So let us take an example. What is the example? Your favorite example? What is that? 1, 2, 3. 1, 2, 3. 4, 5. Let us go negative way. Minus 4, minus 3, minus 2. Minus 1. So this is not at all symmetric. Correct? So let us take A transpose. What is A transpose? 1, 4 minus 3, 2, 5 minus 2, 3 minus 4 minus 1. So what is A plus A transpose? Tell me.
2, 6, 0.
0. Next one.
6, 10, minus 6.
6, 10 and
Minus
6.
6. 0, minus 6. Minus 2.
Is it symmetric? Correct? Let us take the difference of it. A minus A transpose.
0.
0.
Minus 2.
Minus 2.
0.
Come on, this is minus.
Oh, correct. That will be 9. No, 6.
6. So,
4 minus 2.
4 minus, no, 4.
4 minus 2.
Minus 2. So it will be 2. Correct. 2. 0. What is that?
Minus 2.
Minus 2. Sure.
Then 0.
What are we doing?
No,
Yeah.
Minus 6. Minus 6. Sorry.
Minus 6.
And then 2.
2.
0.
0. Is it skew symmetric? Correct? So, and this is an, so this is a very interesting properties with your A transpose and all. Okay. So there are a lot of problems will come. So the matrices is basically you must have seen this is very simple. Okay. So it's very it gives you very you can do so do the many of the problems in a very simpler manner. It helps you to solve many of the linear equations that we will see it in the upcoming classes. So there is a one thing they have written, a square matrix A can be expressed as sum of a symmetric and a skew symmetric matrix. Okay, that you can actually, it's very simple to prove. That's what happens. So what it says is, so shall I remove this one? Yeah, I will remove this portion. So a square matrix, so this is interesting. So your any square matrix, it can be any square matrix. A square matrix A can be written as half of A plus A transpose plus half of A minus A transpose. Oh, sorry. Correct. Okay. So that means a square matrix can be, what is A plus A transpose? That is symmetric, correct? A minus A transpose, that is skew symmetric. Okay, so anyway, we have done all this. We just try to find out what is that. Anyway, we will use the same matrix here. So let us try to see what happens. So A plus A transpose is already we have done, correct? Take half, you have to divide by 2, correct? So let us write this one. So half A plus A transpose. So what this will be? Tell me. 1, 3, 0, 3, 5, minus 3, 0, minus 3, minus 1. Correct? And then half of A minus A transpose will be what?
0,
0,
minus 1,
minus 1, 3, 1, 0, minus 1, minus 3, 1, 0. Correct? Let them add the both. That is half A plus A transpose plus half A minus A transpose. Okay. Actually, you can prove it from your distributive law also. Earlier we did additions, right? There also you can prove because matrix addition follows the same way. So what this will be? Tell me. 1,
2,
2,
3,
3,
4,
4,
5,
5,
minus 4,
minus 4,
minus 3,
minus 3,
minus 2,
minus 2.
minus 1.
Are we getting back A? Okay, so, and you can see, so this is, so if you see, this is a symmetric matrix. Am I right? And this is an skew symmetric matrix. So a square matrix can be written as a combination of symmetric and a skew symmetric matrix. So this is an interesting interesting property with the matrix transpose. Okay, so that's it. So the next class we will see next class we will see go more into how we are going to use this. There's one important type of matrix we missed. I didn't do it for purposely I didn't do it. There's something called a singular matrix. Okay, and there's a very interesting matrix. Okay, so to know that you need to know what to be mean by determinant. Okay, and the singular matrix, why do you mean by singular matrix and all those things? I will show you from the equations. Let us take go to your 10th standard class, and from those equations I will show. So then it will be more interesting to understand it. Okay.